All right, welcome to Graphing Nonlinear Inequalities Part 3. And what we're going to do today is a little bit different from what we've done previous. I'm not going to show the solution by graphing, and that's the reason here is how do I know what to do? Well, this inequality doesn't just have y on one side. What you have here is a nice inequality that just uses x and it's the rest of its numbers. So this is an actual thing that you want to solve. So how do we solve something like this? Well, first of all, notice the form it's in. If this had been equals, we'd have looked at that and said, hey, that's like a quadratic equation. We know how to solve that. Sometimes we use factoring, and sometimes we use the quadratic formula. So with this one here, I'm going to go ahead and figure out exactly where this would equal 0 by using the quadratic formula. So this is negative b plus or minus the square root of b squared minus 4 times a times c, and all of that is over 2 times a. So there it is. That's going to solve where does it equal 0. So we have 5 plus or minus the square root of, now let's see what we get here. This would be 25 and then a double negative, so plus. So that looks like it's going to be 29. And I'm going to go ahead and just figure out what those numbers are on the calculator, which I did ahead of time. And so I got negative 0.19, but I also got another number, and that's 5.19. Okay, so that's where this inequality, that's where x squared minus 5x minus 1 equals 0. So what I'm going to do is kind of, I like to call this a poor man's graph. It's actually just a number line, and think of it as the x-axis. So there's really just the x-axis. And somewhere here there's a y-axis, but I'm not going to bother with it. And I'm going to locate these two important points, negative 0.19 and 5.19. Okay, now these, if I do kind of a poor graph here, so I'm just going to very lightly put this graph in. X squared is a positive x squared, and that typically means it's a parabola that opens up like that. So these two places here, these are the 2 points where the x-intercepts are. Whether you call them zeros, or whether you call them roots, or whether you call them x-intercepts, doesn't really matter. That's what they are. They're really the x-intercepts. And if I know the graph opens up, then here's kind of a simplistic version of what this graph is going to look like. Okay, it's going to be a parabola that does that, right? Now, not a good graph, but that doesn't matter because this isn't about graphing. This is about finding the zones where this graph, okay, and you can think of this as your graph, okay, so this is where the graph is greater than 0. So that means it looks like it's going to be the zone on the left here and the zone on the right. Now, notice there's no equality line here, so I'm going to show that with an open circle. We're not including these points. And the zones we're talking about is this zone off this way. Okay, so that's that zone. And then the zone off to the right. Now, if you wanted to, you could pick a number that's in the zones here. You could plug it in, and hopefully it does produce a number that is greater than 0. But I'm going to go with the poor man's graph. It's a very fast way to recognize which zones have the solution. Now, another way to write my solution, so I say or, I could write it as x less than negative 0.19, and then the other zone is x greater than 5.19. So there it is. This is the solution to this inequality where we're not going to just produce a graph. We're actually going to find those zones that make this inequality true. And that's what we've done. So I'm going to stop there.